Greetings and welcome to our first Monday night coding session focusing on Scratch, brought to you by the Digital Learning Team. This is the first of a month-long series which will culminate with the Hour of Code happening from December 7th to December 11th. My name is Nicholas Gonzalez and I am a Digital Learning Specialist with OIIT. I would like to welcome you to our first Scratch webinar and thank you again for joining us and taking time out of your busy schedule to learn how to code. So here's an agenda of what is going on tonight. We are going to go over the live training schedule and resources page. The rest of the team is going to introduce themselves. John is going to go over what Scratch actually is and why it is important. Then he will start our short tutorial.
Hi everyone. I think everybody's online and everybody's audio is working, so I think we're good to start. Again, if you have any questions, just put it into today's meet, and we've been going back and forth, so I think everybody's okay doing that. I'm the program director for STEM and robotics initiatives at Boston Public Schools, OIIT Digital Learning Team, and I'm hoping to get a lot of you on board for the Hour of Code, and this is our first series of webinar, and I'm very excited to have you here. We'll have a whole series every Monday from now through the end of November doing the, different kinds of coding. So I hope you can join us for the other ones as well. And I'm going to pass it over to Rashmi, who will introduce herself.
Hello, everyone. Good evening. Actually, it's a really wonderful sunlight out here, and welcome to our first BPS Hour of Code Scratch webinar. My name is Rashmi Pimprakar. I am Program Director for the STEM and Multimedia Initiatives, and it's a great pleasure to be with you on this webinar. And I'm going to pass it over to John so that we can get our team introduced and look forward to working with you.
How's it going, everybody? My name is John Laporto. I work for the Dearborn STEM Academy. I am the computer science teacher there, head of the computer science department. And what I want to do is today I want to go through Scratch, which I'm a really big fan of. I'm currently teaching Scratch in 6th, 7th, and 9th grade. We also offer it in 10th grade, another teacher's teaching that. And I'm doing the ECS curriculum in my 11th grade classes. So Scratch, from my standpoint, I think I could probably do 4th grade. And there's actually another version of Scratch it's like Scratch Junior they're still working on. That you can get into for even younger grades. But I would definitely say once you get 6th grade, 7th grade, Scratch is totally something kids could do and have a lot of fun with, and they are. So let me quickly just go through a couple reasons why I personally am in love with Scratch. I feel that computer science is like Nick had said, is definitely needed for kids in the future, in the 21st century, these jobs, the computers are taking over CVS clerks. The kids need to know this stuff. And so I think it's really important we get them at a younger age, so when they leave high school, they have more fluency going into college, and when they get into the job sector, even kids that are really interested in computers, a lot of those kids don't even start programming until freshman, sophomore year of college, and that's only 3 or 4 years of programming experience before going into the professions. Whereas we could easily have kids with 6 years of programming experiences going in with, and what opportunities would that open up for them? So I'm a big fan of computer science classroom for that reason, and also because my background being in math, I find it as practical math. I find it as whenever a kid says, "Why do I need to know this in math?" you can point to code and say, "This is exactly why you need to know this." That when you were playing Call of Duty and you threw that grenade, that's a parabola. Like that's programmed in, and people understand that, and that's the reason why they are so successful in that field. And there's a variety in statistics in programming physics and programming lighting in games and data manipulation. There's so much math in there, and it's finally this great connection where I love when a kid says, "Why am I learning this?" Because there's a real reason, and the real reason's in your pocket vibrating right now because you're not supposed to be texting in class, but you are anyway. That stuff really exists, and it makes me, I don't know, it makes me passionate about it, and I find that Scratch is a great way to introduce that connection between math and what you're seeing on a screen. You know, kids are, as computers get more and more user-friendly, kids aren't learning like we did how tough it can be to use a computer sometimes, and how you have to be very exact with what you tell a computer to do, because now Google is guessing what you're thinking. And it's guessing what you're thinking because somebody was very exact behind the scenes. So Scratch is a great way to show those kids those connections. So what I want to do is I want to jump into Scratch, show you guys some of the basics. We'll do a little project, a little like make your name dance project to kind of show some of the basic blocks, building blocks in Scratch, and talk about how kids can share and kind of critique each other. So we pop over to my screen. So this is Scratch. It's scratch.mit.edu. Scratch was made by MIT Media Lab. So anybody who's tried teaching code before or tried learning code before, there was this disconnect when you were learning to code. At least when I was a kid, I remember learning C++ in high school and hating it, because the concepts I got and the problem-solving aspects I got and some of the math I pretty much got, but this thing kept on erroring when I compile it because I missed a semicolon somewhere. And it would stop you from the problem-solving process right away. You would never get in. And the kids that were more, or the people that persevered, yeah, absolutely got into it. But I found that, like, especially for me, and I see it with other kids that I've tried to teach to program, that there's that roadblock of like errors in typing and typos, where they don't get into the heavy lifting of thinking about what code is. They focus more on like making sure that that everything ends with a semicolon or whatever it might be. Or you end your parentheses, or you got 3 parentheses that are open and there's 4 closed, and that's why this thing won't work. So Scratch allows you to take the concepts of programming, some of the heavy lifting of programming, and get the kids involved in that without getting into, I didn't close all my parentheses and that's why this whole thing doesn't work. And as you get further down the line in terms of programming years down, you can add that extra component. So all right, so here's Scratch. Enough about talking about it. Let's get into it. When you click on Create, it brings you to this online creator. Let's say a project creator. The online project creator it's online. If you're having internet problems, you can actually get a downloaded version, so you can actually install this too on machines. If you're in a situation where you're not going to have internet for some reason, you can install this too. We're just going to use the online version for now. So when you first open up Scratch, you're seeing 3. I'm going to close this tutorial. By the way, these tutorials are great for kids too. This animate your name, we're going to do a little bit of that today. These are great for kids, but we're just going to go through. I'll talk you through it. I'll do essentially what the tutorial does. But I'm alive and real. So here is a stage. And this is where all the action happens. This is where your program is. The best way to describe this is what you see as a program. If I click full screen, that's your program. All the other stuff is happening behind the scenes. So when I minimize it, I've got my stage here, and over here I've got where my script is. Inside my stage is a sprite. This guy down here is a sprite. So the cat is a sprite. It's inside my stage, and inside my sprite is a script that controls my sprite. So just to repeat that, you have a stage. Inside the stage is a sprite. Inside the sprite is code that controls the sprite. For example, if I bring on this when the screen flag is clicked, and I add this motion, move 10 steps, and I add these blocks into my script, when I click on my green flag, my sprite moves. So to add one step further, we have a stage. Inside my stage is a sprite. Inside my sprite are scripts, and scripts are made of blocks. That's the basics of Scratch. These blocks will tell the sprite what to do. Today what we're going to do is we're going to make a small program talking about animating a name. So we are, let me just get this out of here. So the first thing I'm going to do is I'm going to get rid of this cat. So I'm going to right click on the cat and say delete. And then I'm going to create a new sprite. But if you see this guy right here, there are multiple ways to do sprites. I think just as a beginner, the best way is to click on this first one. It's like a little guy's head, a little elf or something. You click on that, and you have this whole library of sprites that Scratch has for you. It's all sorts. And I'm just going to go to letters. And my name is John, so I'm going to go for J first. So let me see, let me find a J I like. And there's a whole bunch. I'm going to go with this guy, J. So for my J, I can click onto my stage. I can move them around where I want them to move. For those who want to get more involved in math, if you see down at the bottom here, you'll see X and Y coordinates. This is a coordinate grid. If you want to start working with your algebra class about what coordinate grids, you're talking about coordinate grids and graphing things, and you want to place sprites at certain places, this is the coordinate grid of where that sprite is placed. So I've got a J. What I want to do is I want to create an event so when that green flag is clicked, I want my J to move 10 steps. So I click that green flag, it moves 10 steps. But I want it to dance. I want it to dance. I want it to move back 10 steps. So here's another great little mathematical problem. How can you get how can you get it to go back 10 steps? Well, kids could say anything underneath the sun, but we're looking at negative numbers moving it back. Now here's another great little mathematical bit here. These two will actually cancel each other out. So when I hit the green flag, the J is not going to move anywhere. Technically, it's actually doing them both, but the computer's moving so fast and it runs through the script so fast, you don't see it do them both. So you need to have some sort of control in there to tell him to wait. So I can add this wait 1 second, and then he moves forward and then back. Forward and then back. We can even add to that by, let's say, repeating it 10 times. And I can put that repeat block in there. Forward, back. If you see, he twitches a little bit back and forth because we don't have a wait between this move and this move. I can add another 1 second right below that. So he's moving forward. Give it a second. Forward, back, forward, back. All right, let's add another sprite. Let's say, let's grab an O. I'll grab this O. So here, this sprite again, I clicked this guy here. I went and picked out an O. For here, I want to try rotation motion. So I'll say when the green flag is clicked, I'm going to have my sprite turn 15 degrees. I can move that right off. So I got O. When I click that green flag, turns 15 degrees. And you see my J is going on its own. Turns 15 degrees. If I want to loop that, I can actually put in a forever loop to get it to repeatedly turn 15 degrees. So now I've got a spin and O. So it's turning 15 degrees. We can talk about how much 15 degrees is. We can, if it wasn't an O, if it was an R, we could talk about 90 degrees. Where do we expect it to be pointing if we turn it 90 degrees? There's a lot of stuff, a lot of guess and check stuff we can play with in this. So now I have this forever loop that's forever turning 15 degrees. And finally, I can add my N. So I go back, I go to letters, and I'll grab this N. And let's look at motions here. We've got these glide blocks. So when I say, if I go back to my motion, you see glide there. Glide 1 second to a specific coordinate. If we want my N to come over here, you can see where my mouse is. If you look below it, I can't really do both. You see down here. But you see where my mouse is, the X and Y coordinates are changing. Right now the Y is not changing because I'm staying on the same Y. I'll just move it a little bit. And I can say, all right, I want my N over here at 187, negative 1. 187, -1. Now when I click this green flag, the n will move to 187, -1. If I want it to move back, well, I can drag it back, but that's not the fun way to do it. Let's tell it to go back here. Where am I at here? It actually helps you out. I'm at 76 right here. You can see it. That n is at 76. So if I click the green flag, it moves over to 187 and then moves back. Every time I click it, it moves over, moves back. If I want to loop that, I can add a forever block there. And I've got my dancing name. If I want to add more to this, I have stages and backdrops. So back here, so here we've got sprites. These are all my sprites. Here's the code. Here's the script in each sprite. Now I've got a stage and a backdrop. And I can actually put script in here too if I wanted to. But right now we're not going to do anything, but we can. We can do things like change backdrop, switch backdrops, go to different backdrops. There's quite a few events we have in our backdrop. I mean, quite a few blocks we can have in our backdrop. For our backdrops, if I click on the backdrops here, you'll see there's a little, you can download stuff, you can pull it from the internet, you can actually take pictures to put as your background, or you can take from the library. And the library has this great, I mean, it's getting better and better every day. I think every couple months I get on this thing and I see, or they get on this thing and there's a whole bunch more. You know, there's fantastic stuff here. So I will take this nice pathway as my background. And now my background is set up to be this nice little garden. Isn't that pretty? So there you have it. So when I click the green flag, I now have and I'm freezing up here. Here we go. The green flag, I now have an animated J that you can't really see because it's in the grass. I'm going to move them out of the grass. Put it down here. An animated J that goes back and forth because the script is telling it to move 10 steps, wait 1 second, move -10 steps, wait 1 second, and repeat this 10 times. I have an O that's spinning uncontrollably because it's forever turning 15 degrees. You know, you can play a game, if you change it to 5 degrees, what happens? Why is it going slower? Why would it be going slower if it was 5 degrees and if I change it to 90 degrees, is it flying? What is it doing? It's a lot of investigation that we can do. And then my N is going back and forth, gliding to 2 coordinates, back and forth. Great game to play is like, all right, well, what if we wanted to go up here? How can we get them to go up there? What if we wanted to go to 3 different coordinates, 4 different coordinates? So there's a lot of mathematics that you can play into this. It's just fun. I mean, it's creative. It allows the kids to kind of build their own thing that represents them while still dealing a lot with math. Extensions to this. So right now, that would be your class in terms of animating your name. The kids you could go through what different blocks are. You can go through what a background is and what sprites are, and then have the kids work for a good 35, 40 minutes on this and then sharing out. But if you have kids that want to push further, there are costumes. So inside, here's your sprite. Your sprite, think about your sprite as just like a container. Your sprite has just script in it. And whatever your sprite looks like is completely up to the costumes. So when I click on costumes, I've got an N block. This is the sprite. This is what I picked out to be the first costume when I clicked it here. But I could change that, or I could add new costumes. If I add a new costume, let's say I say letters, and I go to, let me grab a different type of N. Take that guy. So now I've got another. So I've got another costume. I can have my N look like this. I can have my N look like this. I can also create a script that says, when that green flag is clicked, I want to switch back and forth to what my N's looks like. So I can have a loop inside my forever loop. I can say looks, switch costume, or next costume. Switch costume will take you to a costume and you'll stay there. Next costume will course through the costumes. So I could say forever And then I definitely want to slow it down a little bit. Maybe make it half a second change. 0.5. So it waits and goes to the next costume. When I click that green flag, changes back and forth from costumes. Finally, if you want to put in, so we have costumes of what the sprite looks like. If you're brave, there's sounds. And this is what the sprite can sound like. If you put in sounds, so when I go to my sound library, I can pick out sounds here. And I'm going to spare you guys a lot of these sounds, but some are pretty funny. When you put in sounds, you can also set up scripts where the students are, if you'll see, making sounds play. So there's a variety of stuff you can do to kind of extend and allow the kids to be more creative. And if you have more advanced kids and you're worried, we have if then statements, if then else statements, wait until, repeat until. You also can get into making their own blocks, so they can actually, technically it's making their own functions that'll return different values. You can get very, very advanced with this without having to worry about typing the wrong, missing a semicolon and getting frustrated. So it allows students to be programming and not even think that they're programming, kind of, they're not, it's fun. It's fun, I guess is what I'm trying to say, yeah. It's fun, and programming is fun too. So let me just double check and make sure I've hit everything I want to hit. If you want to make an account, so right now I've got here, and you can choose whether you want to make an account with the kids after they build it, or after they build their make their name dance project, or beforehand. If you want to make an account, you can join Scratch and set up a username and a password. The only hiccup with the username and password when they join Scratch is you need to make sure that they have an email they can get to, because they have to validate their email address. If they don't have an email they can get to, I'd say use their BPS email, but if they don't know the passwords or their birthday's not working or whatever it might be, I've in the past, if it's a one-off thing, I've just told them to use my email address. And then I went through, and while they were working on stuff, I was just validating emails all the way through. Once they've done that, they can sign in. So now I've signed into my account. It's saved my changes, and you'll see here it says share. So the kids can then click share, and that'll allow their program, their project, to be viewable to the outside world. Now it's not pushed out there to the front page. It's just readily viewable. It just allows them to say, you know what, I'm done with this enough to let the outside world see it. Once that's done, it'll take the student to a different screen, and this screen is their project page. Now right now my project page is called Untitled 3, so let's put a name to this. We'll call this John's dancing name. There's John's dancing name, and when I click the green flag, it makes my name dance. You can see inside, so this is actually what my page would look like. You can see inside my code. Any student can go into any project and see inside the code of how it's made. You go back to the C project page. You can write instructions for how to work. Click the green flag to see my name dance. You can write instructions, and you can also comment. The best part about doing this is that if you as a teacher have set up a project, so I'll go into my stuff, me as a teacher, and I have a ton of stuff in here. Here is, I have these studios. You can make a studio. If you set up your username and password, you can click a new studio, say new studio, and you can create studios. And we've been working on animation, and I have a 9th grade animation hand-in where the kids have gone to this URL, and after they've clicked share, they need to click share first. And keep in mind, they will not be able to click share unless you have authorized your email. So as long as you've validated the email, then they can click share. So the process will go, kids sign in. If the kids are using your email address, you then validate all their emails. So validate all their accounts. Once that's done, they can click share when they're done with doing what they're doing. And then they can, once they click share, they can go to your studio's URL and say add project. So this is my 9th grade right now. They're working on stuff, and I can look at catastrophe, which is one of my students' programs. We're working on animation and how animation works, which is actually changing costumes. And we can look at what she's done. So what I do in my class is I have all the students go into the studio, look at each other's, and then I have prompts for comments they should leave. So I'll have, one prompt would be, how did you do, and then ... And they'd have to write in, how did you do a certain thing? Or they'd have to write in, did you ever think of doing ... And they would write in the comments what, based on those prompts. So if we click on Ileana's, this is her animation that she's made, that she's programmed through of a cat. I think, yeah, the cat gets hit by lightning. And then you got a guy crying. And I think she's a big Doctor Who fan. So this is where things could go. And if you see inside, it looks very simple, but look at this. There's all sorts of fun, great math and code and juicy, good stuff in there. And kids, when they look at this, are asking also, wait, whoa, hold on. What does this ghosting effect mean? Why do you change it by 100? Why do you then change it by -56? What does that do? Why do you repeat it 2 times? And we have shout outs at the end where kids will look at each other's code and they'll be like, oh, that one with the guy crying in the rain, let's put it up on the board. And we throw it up on the board. And the kids make sense of the code. Why would we repeat 2 times and then wait 3 seconds and ghost effect by -56? Why -56? What's that doing? What's that doing to this cloud? So you can go through and kind of have the kids reverse engineer each other's projects.
Our students are looking at jobs in agriculture, manufacturing. Computers are everywhere. It's gaming, let it be health sciences, and it's critical that our students know coding and know how to read and write code. And to John's point, I really want to reiterate, there is a really great graphic that I'm sharing, which talks about how untapped the opportunity is with our computer science graduates, and how we are not able to bridge that gap, and how we are not able to offer those opportunities to our kids. So it's an awareness campaign for us as well, and also recognizing how we can reach our kids here through different types of programming models, to different types of contextual lessons, and as well as programming challenges that allows them to explore their own creativity. I would also like to bring your attention to one of the courses. It's a partnership that BPS has with NSF, Baytech, and EDC, that brings in a course called Exploring Computer Science, which allows for some of these advanced courses to be offered in BPS. And I would like John to add to this as well, because John offers this course with his 11th graders. Correct me if I'm wrong, John.
ECS, yeah.
Yes. So this is one of our online sites. Let me quickly switch to that. And there is a whole lot of curriculum available to us via ECS, the NSF website, that allows us to download a lot of the, give me one quick second, perfect. So there are 6 units that we work with. Each unit approximately takes 6 weeks to complete, but of course there is room for variation, and I would urge John to talk about his implementation experience. But sort of the first model is more so about human-computer interaction, which sort of merges the HCI, which is human-computer interaction, with ergonomics, brings in some real-life situations, and the students are interacting with those. It also, the Unit 2, which is about problem solving, kind of emphasizes about different techniques that are involved with problem solving and how we can use them to break apart a problem, to look for solutions piecemeal as well as a whole. And then we go into the web design module, which allows for students to explore their creativity and go into, sort of build onto their knowledge of algorithms, sort of look at abstractions in a more holistic way, and come up with not just a web page design, but a project that they can then engage with as they improve upon their algorithms.
I like this because I think I said before, that we're getting into an age where students don't understand why Google can guess what they're thinking, and it's not because it's because it's almost like, it's the water they're swimming in, like they don't know it's there, and that's fine. I mean, that's to be expected. But I think it's really important that kids start to dig into the concept of who made Facebook. And you're gonna get kids, or you're gonna get adults saying Mark Zuckerberg made Facebook, and then you're gonna sit there and you say, when was the last time you looked at Facebook and looked at anything that Mark Zuckerberg put on Facebook? When was the last time you looked at anything on Facebook that anybody from Facebook's dev team put on there? You're looking at everything you and your colleagues put there. And then comes the question of, if you made, a couple, I don't know how much Facebook's worth now, billions. If it's everybody who's put their things on there, where do you stand in that? Like, what is the internet now? Because it's not like it was 10 or 15 years ago, where there were people that were sat there and they built a web page and people went to the web page. Now it's everybody putting things on Twitter that makes Twitter worthwhile. And then on top of that, Twitter's learning from you. And Twitter's or Google is advertising to you and selling what you've put on there as their asset, and you haven't been paid. There's a dynamic, and there's a huge discussion there to have with 11th grade or 12th grade student to say, is that okay?
So this is the BPS Hour of Code website, in case I did not show it last time. It is tiny.cc/BPS HOC 2015. So this is the BPS Hour of Code site that we set up just for this week, and not for this week, for the Hour of Code week in December. And this is the graphic that shows you what type of activities you can do at different grade level. And if you scroll down a little bit more, there's a link to PD opportunities. And if you scroll down a little bit more, there is a link to the pledge. And again, the pledge is where you sign up to let us know that you intend to do this, and then we will keep in touch. And as the December date nears, we will be sending out more information regarding contests and raffles. So definitely do sign up on that. And this is the list of schools that are already signed up. So if you don't see your school here, or if you see your school but there's only one teacher signed up, then that's a sign to get more people. That's the sign to sign the pledge and get more people to sign it as well. In terms of the Hour of Code website, this is the official Hour of Code website. It's hourofcode.com. And again, every teacher who signs up on this site using going into the sign up your event link, everybody will get a $10 gift card to Amazon, iTunes, or Windows Store. And if the entire school participates, then you will be eligible to enter a raffle for $10,000 worth of technology.
So we'll make that clear.
Oh, every teacher?
Yes, every educator. So make sure we don't promise kids this.
Oh, the $10 card?
Yeah.
Yes, the $10 is for the teacher, not the student. So a teacher signs up, sign up your event, meaning your class, and then the teacher will get the $10 card, not the children.
Like 75 cents a kid.
But we will be doing some prizes for students. We're hoping to set up some competitions for students. So, for example, it could be like whoever that comes up with the coolest Scratch game. We don't have the rules and details yet, so we haven't announced it yet, but we're working on that, and there will be student prizes from BPS at different grade levels. So look forward to that.
Here is our official BPS.
This is our official BPS Hour of Code certificate, and we hope that all of you participate for the hour and forward for the whole year in the computer science exploration.
There's a question about if Scratch Junior is available on the Chromebooks. If you look at my screen, I don't know how the management's going. I have an app. There is an Android app for it. Scratch Junior. I'm sorry, Scratch Junior. Scratch Junior. Yeah, there's an Android app for it. So if you have the privileges to install apps onto your Chromebooks, you might be in luck. But definitely test it before making a lesson plan around it.
I'm going back to the Google Classroom site, and I just put up a new assignment, which is an exit ticket. It's a very short Google form. If you want to sign up on that, just to give us some feedback, we appreciate every piece of feedback. We're going to be doing weekly webinars, so any type of feedback you can give us in terms of how to improve our webinars, we deeply appreciate it. So that's just this link. It's only 3 questions. Hopefully it'll only take you about a minute to fill out. So thank you very much. Anything else we need?
Let's just say thank you.
Yeah, thank you.
So thank you everybody for joining us, and we will again be having a lot of different webinars. We hope to see you again for some of the other webinars, and I'm going to be using the Google Classroom site to post more resources, some of the stuff that was mentioned through this webinar. I will also be taking the transcript from the today's meet and putting it up on there as well.
And let's say thank you to John for joining us tonight.
Oh, no problem. My pleasure.
Thanks, John. Thank you for coming out of his day and coming over here to help us out. It's great to have you. Appreciate you. Very resourceful.
Thank you, everyone.
Yeah, thank you guys.
Signing off.
Thanks, everyone. Signing off.
Signing off.
Bye.
Spread the word.
Spread the word.